the goal of this presentation is to give you an overview or some sort of introduction to the Swagger toolchain and maybe give you some fresh ideas for your next iOS project. So I don't come up here spouting a new world order. It's mainly just some fresh ideas. It's 8:38. I'll keep track of the time. So how often have you started a project and you've implemented Alamofire, begun thrashing out some domain models, you've waded through some custom operators maybe if you're so fancy, and you've ended up with, just to end up with Swift representations of your domain model that you've got online. Where do you get these response formats from? Where's the documentation? Obviously, you've got an API. You're writing your local implementation. Every new app. Is this painful? Is doing this process every new app painful? Is it boring? So it is. On a recent project that's still ongoing and yet to be in production. So take that as the grain of salt. I'm not spouting something I've put into production yet. But I was tasked with first coming up with the API specification for the app, and that I wasn't going to develop that API this time, and so I thought, well, given this is my task, this is a great opportunity to start with the API specification, and I can use it for both the documentation for the third-party developer writing the API, and maybe I can use it to actually generate the Swift code that the app will use. Sort of kill two tasks with one thing in the middle. So this is a little bit about my journey, and maybe hopefully introduction to other people as well. So got kind of 4 topics. We're going to go quickly into what is Swagger. We're going to do command new project and do a little bit of a demo. We're going to go into the code that sort of we generate, because it's all about automatic code generation. We're going to go into that code a bit deeper than just the top level. We're going to try and improve that generated code. Not too much, just really quickly, just to show that you can do more than what it just generates. And then we're going to go, well, but why? And but why is a little bit of, we can kind of all yell at me or yell at each other about but why. So what is Swagger? Who's heard of Swagger? All right, okay, good. I don't have any slide notes for what is Swagger. The second question.
Well, they might have heard what Swagger is, but they don't know.
Oh, maybe, yeah. So the question to put in your mind is, I assume 90% plus of apps talk to some sort of JSON, HTTP JSON API. That's the general gist these days.
Still use XML. It's awesome.
And there's always an XML person that's invited.
Hey, that's tight.
So my question is, what does your API use, or your API developer, or the third party that you use for an API, what do they use to test that API to make sure that it's returning the right response? As an iOS developer, or an API client developer, you need to know that format. Where's the documentation? That's just the question I always start with. So Swagger is a project used to describe and document RESTful API. So its purpose is to basically create that documentation that people can read. And it's a specification that is based on this thing called JSON schema. And if you've heard of Swagger, you've probably heard of JSON schema as well. Yep, a few people have done. So JSON schema is the kind of underlying thing, and it's a vocabulary that allows you to annotate and validate JSON documents. So JSON is just, it has its very simple format, and you receive a response that's just kind of, maybe it's this. Maybe this is you get a JSON object, subtitle, tickets, title, URL. The question is, well, how do we describe this in a way that we could potentially validate or test or even document? What are those fields? They're not just strings, key values, there's more to them. So that's what JSON schema aims to create, is a sort of a format around that. So this would be the JSON schema for this object here, and you can see that the title of this object is event. It's a type. The type of it is an object, and you can see the properties of subtitle, tickets, title, URL, and you can see how it's sort of descriptive. It's got a type, it's got a format, and these formats actually do mean something. They're defined by the spec, and it also, what's most interesting to, I guess, client developers would be the required bit. These things are not optional. in this case. So this would, the object previously would not be valid if it didn't have those two elements. This is, the JSON schema spec is pretty easy to follow. It itself is written in JSON. But as I said, Swagger is designed to reason about or define RESTful APIs. So RESTful APIs are HTTP based, mostly. I'll assume that they are. So this is an example HTTP request. We're going to get melbournecocoaheads.com/API/events. That's pretty standard. And that would return a pretty standard JSON response. So you've got a content type, you've got no case headers. I need to put case headers in, but you end up with an events array at the root, and you end up with those events we just saw previously. So that's a pretty standard HTTP response. If you take the JSON schema example and then sort of apply it in the Swagger example world, you end up with, this is YAML as well. I've changed the format on you, but everyone can read both, I'm assuming. It's very similar. So this would be a Swagger spec for the previous request and response. You're also defining JSON objects down at the bottom here, but you're also, what's more interesting is you're defining the request paths and the response, or the request action, and the response types as well. So you can see you've got my paths of /events. I'm going to get, and I expect a response of events response. And this events response down here defines that events key, and then that's full of event items. So you can just see it's this sort of cascading definition file. So the Swagger toolchain is a set of tools based on people generating these specifications for their APIs. So what the Swagger toolchain can do, or there's open source projects that do this, the first thing they do is validate that your Swagger spec is valid, because it itself is a JSON schema. So there's like so many layers, it's quite interesting. But with your Swagger spec, you can then validate your API's response. So you can do a HTTP request, get a response, and say, well, is this valid relative to my Swagger spec? You can also generate client documentation because it's all there. The descriptions are all there as to what it should be receiving. You've even got nice things like description. I've left a few other elements out, but that is basically documentation. Why couldn't you render that to HTML when you can? And the third thing that I'm most interested about tonight is client code generation. Swagger.io and openapis.org are kind of the roots to start with on those elements.
As a note, it also server code generation.
Yes, it can generate code on both sides, which comes to my pros for this approach at the end of the presentation. No, but I mean, no, it's true. I did say it's explicit as client, but yeah, it can do client and server as well. So let's try a command kind of new project demo here, but this is kind of what I'm going to go over. I've built an API for Melbourne CocoaHeads events. They're on the website. It's been there for years, but I updated it for this presentation so it fits some sort of spec and it works. But on doing this, you hit CocoaHeads.com, melbournecocoaheads.com/events, and it'll return you the JSON blob of the events that are upcoming events. Events, hack nights, anything else that's on the website. Not Meetup, but Meetup also has its own API, but this is just for CocoaHeads. So I've written an API spec for that, and let's see kind of where that goes from here. So the first thing I'll do is I'll jump back to web browser land, and if you, I've put a new repo. Oh, that's terrible. That's all right. I put a new repository up of the events API spec on Melbourne CocoaHeads, and you can see this is kind of what I posted before. You've got an API spec that's got descriptions, it's got details, it's got the host, it's got base path schemes, and then you end up with paths down in the middle here. And you can just see it's very straightforward. You've got paths, events, get, description, responses, the schema of the response, and then some examples. And examples are just the JSON response pasted as YAML. Your definitions down the bottom describe those events, those response types. So event response is just a root object of events. Events is required, and then it has an array of events. So these events are defined down here. And they're very simple. They're basically just strings, but most of them are required. And these are the properties. You've got address as a string, address display as a string, event type is an enum because it can only be meetup or hack night. Sorry, I haven't put in NS breakfast, but it's meetup or hack night. And it just goes on and on and on. These definition files end up thousands and thousands of lines long, which is probably a con to my thing. So with this 120 line YAML file, given that it's a valid Swagger spec, you can immediately generate API documentation from it. So from here, if you post it up to certain third parties, you can get all of it displayed nicely in HTML. And you can say, okay, here's my events API, and I've got a get. And you can tap on that, and you can actually see, switch to example, you can actually see what it would look like. It's just basically displaying the response, and this is great documentation. This is what we're actually handing over to our third party to develop. We have a lot more comments, and it renders Markdown, but we literally use a YAML file rendered like this to display our documentation across the wire. But how do we generate our Swift code from this? So, as I said, it's a GitHub repository. It is a Swagger spec, so I'm going to jump into terminal land. Here we go. All right, so I'm in my spec repo, and you can see here that I've got my Swagger YAML on the right-hand side. Generating the code is one line. Given I've got the dependency installed, which is called Swagger Codegen, you generate the Swift 3 into an API client directory. It does its thing, and you end up with these files that it's generated here. So let's see what they do. I'm going to go into stop tasks. Not that one. This will be my most perilous live demo yet. I'm going to do a new project from scratch, and we're going to jump in, and I'm going to call it demo. I'm going to save it in my Scratch directory here. And how would you integrate with this? I'm sorry about that, actually. What I'll do